Hey, this is Mr. Beckstrom in statistics, and I'm going to take a look at creating a sample space, and then from that sample space, creating a probability distribution, answering a question that we had. So I wanted to do a question that I had growing up, and that was when I was playing Monopoly with my family. We'd often roll the two dice and add those two dice together. And I always wanted to know, like, what are the chances that I was going to roll a 10 and get on Park Place, or what are the chances I was going to roll a 2 and go to jail? That was always kind of a question I had. And so when I first started to learn about statistics, that was kind of a neat thing. I wanted to know, like, what were the probabilities of all of those sums? Like, how often was I going to roll a 12? How often was I going to roll a 7? And this is one of the ways to do it. So the first thing that we want to do is create a sample space, and this is actually from section 4.1, and we're going to do it with two dice. So each of those die has 6 sides, and the size of the sample space is done in different ways, and this is in order to find out how many rows I'm going to have. I'm going to use a little trick that I learned. I haven't actually seen this in the book, but they have different ways to do it as well. But if I actually take the number of choices that I have on each die, which is 6, so I have 6 choices on each die because there's a 1, a 2, a 3, a 4, a 5, and a 6, and I take that number and I put the exponent to the number of objects that I have, which is 2. That's going to be the number of rows that I'm going to have in my sample space. So I take the number of choices that I have, and I roll, and I take it to the exponent of the basically the number of procedures that I have. In this case, it's the number of dice that I'm rolling. And this is going to be the number of rows that I'm going to have in my sample space. And the way I always do it is in my first column, I'll kind of divide it up. So since there's going to be 36 rows, I'm going to equally divide it between each of the choices. That means there's going to be 6 1s, 6 2s, 6 3s, 6 4s, 6 5s, and 6 6s. And then my second column, which is my last column, is going to be alternating. So it's going to be 1 2 3 4 5 6, and so on and so forth. So I'm going to go ahead and get that put in here. I'm going to pause the video so you don't have to sit here for that, and then I'll be back in just a second. All right, so here is my rough sample space here. Notice that there are 36 pairs of numbers here. So in the first column, I did kind of did it in 2 different main columns here. But my first one, I did 1s, 6 1s, 6 2s, 6 3s, 6 4s, 6 5s, and 6 6s. And then in the second part, I did 1 2 3 4 5 6, and then I repeated that 6 times. So this is every single possible combination that I could get when I throw 2 dice. So for example, the first number could be 5 and the second number could be 2. The first number could be 3 and the second number could be 4. So every possibility here shows up exactly 1 time. The first number could be 6 and the second number could be 6. So this is called a sample space, and this is something that they talk about a lot in section 4.1. They talk about it when we're flipping coins. They're talking about it when we're having children, as far as boys and girls. So this is what the sample space looks like here. Now, what I want to do is I want to create a sample space, excuse me, a probability distribution for the sum that you can get on 2 dice. So we're going to, hopefully you've already taken a look at section 5.1 and read it. So we need to first start with a random variable, and in this section we're looking at the discrete random variable. They talk about the definition of that on page 187. So what I'm going to do here is I'm going to start making a table. Let's go ahead and use the ruler for this one. So I'll make it a little bit nicer here. Alright, so I got a nice view, and I probably should have done that. Microsoft Whiteboard has its good parts and its not so good parts. Okay, so it's going to look something like this And let's get rid of the ruler here. So this is our discrete random variable over here. And this over here is going to be the probability of that event over here occurring. The probability of the event occurring. So when we talk about what are the possible sums, that's where we add the two dice together. What are the possible sums that we can get on two dice? Well, we know the minimum that we can get is a 2, right? Because we can roll 2 ones. So the minimum would be a 2, and the maximum would be a 12. That's if we roll 2 6s. So a 12. I'm not going to write it in yet because I want to write all the rest of them. So we can actually, we should know that we can get a 3, we can get a 4, we can get a 5, we can get a 6, we can get a 7, we can get an 8, we can get a 9, we can get a 10, we can get an 11, and we can get a 12. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 different possible sums that we can get when we roll two dice together. And these are all the sums. So what's the probability of each one of these? Well, let's go ahead and start with the most extreme values. How many ways are there to roll a 2? Well, out of all 36 of these ways, there's only one way. There's only this way right here. If you roll a 1 and a 1, all these other ways are more than 2. So that is a 1, I'm going to write it like this, out of 30. Let's see if I can write this a little bit smaller. 1 out of 36. 36. And that is approximately, if we use our calculator, alright, so if I just do 1 divided by 36, I get about 0.027. So that's about 2.7%. So I'm just going to, you can either leave that as a decimal, so you could put that as 0.028. Usually we go to 3 decimal places because we would round it, or we could say 2.8%, but I'll go ahead and leave that 0.028. And we should notice something there. And if I bring that back up, 0.028. There's also another value here that there's only one way to get, and that is a 12. There's only one way here to roll a 12, and that's if we get a 6 and a 6. So that's also going to be a 1 out of 36 chance. And so that's also going to be a 0.028. All right. Now, let's keep going inwards. How many ways are there to roll a 3? So we've kind of got rid of those. Well, to roll a 3, I can roll a 1 and a 2. And I can also roll a 2 and a 1. And that's it. There's no other way here to roll a 3. So I've got 2 out of 36. All right? And the same thing for 11, right? Because I can roll a 6 and a 5. Or I can roll a 5 and a 6. So that's going to be 2 out of 36. So to find those, just go up to the calculator here. And I do, oops, 2 divided by 36, which should be twice that. So it should be about 0.056, but I'll go ahead and put that in there anyways. Might be 0.055. Let me see, times 2. 2, well, I'm doing it, it's not showing, but 2 divided by 36 is 0.0, rounds to 0.056. So 0.056, and this one will be the same, 0.056. And we'll see if we keep doing this, that it'll keep working out the same. 10, we're going to find 3 ways to get a 10. You can get a 6 and a 4, you can get a 5 and a 5, and you can get a 4 and a 6. So that'll be 3 out of 10. The same thing with 4. You can get a 1 and a 3, a 3 and a 1, or a 2 and a 2. So those will be 3 out of 36. And you can keep going all the way you get down to 7, which is going to be 6 out of 36. And put all of those decimals in. I'm not going to go through each one of those. You can go ahead and try those yourselves. But we're gonna have some requirements that I want to talk about in order for one of these distributions or tables to be a probability distribution. All right, so here's the 3 requirements, and these are also on page 187. And just kind of wanted to explain these while we have the probability distribution up. So the first one is that there's a numerical, not categorical, but numerical random variable x. So here's the random variable x, and this has to be numerical. That means it has to be something that can either be counted or measured. It can't be categorical. You can't have like colors, or you can't have jersey numbers, or something that doesn't represent either a count or a measurement. So it has to be numerical. Which this one is, and its number of values are associated with corresponding probabilities, which they are. This 2 here is corresponding with this probability here, the 1 out of 36, or the 0.028. So this first one here is met by this probability distribution here. Now the second one here says the sum, that's what this little weird E symbol is, which is a capital sigma in the Greek world. The sum of all of our probabilities, that's what the P of X stands for, of all our probabilities is equal to 1. Now I didn't do all the probabilities, but if we were to add 1 over 36 plus 2 over 36 plus 3 over 36 all the way up to plus 6 over 36 plus 5 over 36 all the way down to plus 1 over 36, we'd actually get 30, and add them all together, we'd get 36 over 36, which is equal to 1. And the same thing with these decimals. We get something very close to 1. Now we might get a little bit of a rounding error because we had to round on those. You saw that with the calculator. But as long as it's either 1 or very close to 1 because of rounding errors, that's what we're looking for here. And there's quite a few examples in chapter 5.1 where they don't add up to 1, and those are not considered probability distributions, and you'll see those in your homework as well. So it's really important to weed those out. And the last thing is that every probability here, for every individual value of the random variable x, so all of these values here all have to be between 0 and 1. So you can't have any negative values. Notice none of these are negative. And we can't have any values that are greater than 1 either. So you can't have anything like 37 over 36, which is greater than 1. You can't have 5, which is greater than 1. Now you can't have 5%, because 5% converted to a decimal would be 0.05, which is less than 1. So all of our probabilities have to be between 0 and 1. And so if all of these are met in this distribution table, then we consider that a probability distribution table. All right, so try some of these. Hopefully this kind of brings a little bit of what you're reading together. Make sure you're reading this and trying these examples. And please let me know if you have any questions. And if you put some comments or ask some questions in the forums, please shoot me an email as well, just to let me know that they're there, because sometimes I don't get notification of those. All right, thank you everybody, and we'll see you soon.